Hello, and thank you for joining the Biofuture Summit Roundtable on Aviation Biofuels. The name of today's session is Aviation Biofuels Takeoff. My name is Gerard Ostheimer, and I am the founder and the CEO of a consultancy called Biofuture Workshop. Our panelists today will discuss the challenges and opportunities to scale up the biojet fuel industry in the short, medium, and long run, taking into account the broader context of international efforts to tackle climate change and of the International Civil Aviation Organization's Carbon Offsetting and Reduction Scheme for International Aviation, known very well by its acronym CORSIA. I look forward to hearing from our panelists on the latest developments in the production of aviation biofuels and looking forward to hearing about their plans for ramping up production. Our panelists today include Ms. Jane Hupe from the aforementioned International Civil Aviation Organization, where she is Deputy Director of Environment. We are pleased to welcome Mr. Landon Loomis, Vice President at Boeing. We are also pleased to welcome Ms. Maria Carolina Grassi from the Roundtable on Sustainable Biomaterials, where she serves as the Business Development Lead. We are joined also by Sami Jauhiainen from Neste. He is the Vice President for Business Development, specifically for renewable aviation. And we are very happy to welcome Mr. Pedro Mancuello Pérez, who is the Vice Minister for Industry and Trade for the country of Paraguay. With no further delay, thank you again for joining our session. We look forward to receiving and responding to your questions on the platform Hupe. Thank you.
Good day, my name is Jane Hupe, and I am the Director in charge of the Environmental Program in ICAO, the UN Specialized Agency for International Aviation. Today, I'll be sharing the ICAO work on sustainable aviation fuels and its importance to reduce the climate impact of international aviation. And let me start by saying that it's going to be a flying future. From new aerial urban mobility vehicles to an increasing demand for global connectivity, aviation activities are expected to grow, but the public no longer accepts the emissions footprint that come with air travel, and therefore, various solutions for reducing CO2 emissions are under consideration. And the increasing use of sustainable aviation fuels will be paramount for this future. Currently, ICAO has an aspirational goal of a carbon neutral growth for international aviation from 2020 to be achieved by a basket of measures for reduction of CO2 that comprises new aircraft technologies, improved operations, sustainable aviation fuels, and CORSIA, ICAO's global carbon offsetting and reduction scheme for international aviation. We aim as much as possible to reduce aviation emissions in sector measures, but to ensure that the goal will be achieved, we have CORSIA. ICAO is also currently assessing the feasibility of a long-term goal for international aviation emissions reduction, and the contribution of sustainable aviation fuels will really be key. We really are looking into more ambitious climate goals in all sectors, and ICAO is part of that effort. The main advantage of sustainable drop-in fuels for international aviation is that they do not require changes to the aircraft or its fueling infrastructure, and it can be mixed with traditional aviation fuels. The technology is proving, and as I said, close to 330,000 commercial flights have already taken place, putting aviation fuels as a perfect measure to be implemented in the short term. Before we move to the details of ICAO work on SAF, it's worth it to recognize that we have come a long way. It's an impressive evolution that we have seen in the last decade. 12 years ago, in 2019, we were still addressing the technical feasibility and the safety of sustainable aviation fuels. There were no certified production processes for SAF, nobody would ever imagine that you would be flying with used cooking oil or fuel produced from the recycling of cotton t-shirts. And there were very, very few demonstration flights. Then in 2009, ICAO held the first ICAO conference on aviation and alternative fuels in Rio de Janeiro. This conference recommendations had really a seminal importance on the ICAO work on SAF, setting the direction of the developments to come. When in the next thing was that in 2012, we have seen a flight from our Secretary General that flew from Canada to Rio de Janeiro to the Rio Plus 20 conference in 4 consecutive flights powered with SAF. That was to show that the SAF technologies were already mature and safe. And you know, that I think really was a benchmark. And from there, we saw a very quick evolution on sustainable aviation fuels. In 2017, we had our second conference on aviation alternative fuels. We were no longer asking, can we do that? Is it safe? But we were really discussing important recommendations that would encourage and set the global harmonized approach for the production and use of sustainable aviation fuels. And finally, in 2018, when we adopted CORSIA, we had included in CORSIA provisions that provided credit to the environmental benefits of sustainable aviation fuels, as we'll be seeing later in this presentation. But it's of note that in 2018, we had then the first policy, global policy that could incentivize the use of sustainable fuels for our sector. So, but what exactly is the role of ICAO? We have been talking about what ICAO has been doing historically, but what's the role of ICAO for sustainable aviation fuels? So we are UN, we have 193 member states, more than 80 international organizations contributing to our work. And when you fly an airplane, you are flying on more than 12,000 binding international standards that were developed over the years. So facilitating international civil aviation, putting policy standards, that's our main objective in ICAO. So to facilitate SAF deployment and the development of SAF, we have 4 main activities. First is exactly establishing, the global policies, measures, and goals, such as the CORSIA and the goal of carbon neutral growth from 2020 and looking into the contributions of SAF to that, but then developing globally accepted standards, sustainability criteria, and life cycle methodologies for SAF use in CORSIA. Also organizing events for information sharing and outreach. And one big example is what's happening right now is the ICAO stock taking seminar. That is our process to determine the long-term goal for aviation. And last but not least, sharing information and best practice by means of the ICAO website and ICAO publications. And there is a very, very rich material that you can find in our website. One that I would like to highlight is the ICAO Global Framework for Aviation Alternative Fuels, the GFAF. That was one of the outcomes of our conference on aviation fuels. And this is the main repository of SAF-related information that you can have. It includes over 600 news and announcements dating back to 2005. It has details on SAF-related projects and answers to frequently asked questions and much more. We have a map that can tell you right now what are the commercial flights that are flying in the sky with sustainable fuels. We are not flying much international these days due to the pandemic, but if there is a flight and it has sustainable fuels on board, you will see it immediately and you'll find information on that. In the ICAO website, you also find information that clearly illustrates the progress that we have achieved in the area, such as on the conversion processes that were certified, what international airports are now regularly distributing blended SAF for anyone that comes into the airport or departs the airport. And as I mentioned, we have 330,000 flights, commercial flights that have already taken place. Now, I would like to move to CORSIA, and I'm very pleased to inform that CORSIA implementation is on track. You can see by the slide that that was a huge undertaking, lots of work, but CORSIA, it's a reality now. Its pilot phase started on 1st January this year. And we have all the standards, recommended practices, implementation elements, and guidance material published on the ICAO website. CORSIA is a global offsetting scheme, and it ensures that the carbon emitted by international aviation operations do not pass the baseline. But embedded in the scheme is a policy to incentivize the use of SAF. So this is the most important thing. Airlines that need to offset on the CORSIA, so you have the baseline, you calculate the emissions, and if that year one airline has passed the baseline, they have either to offset or they can use sustainable fuels, and they deduct the benefit accrued from the use of sustainable fuels on a life cycle basis from the volume of offsets required for their compliance to the goal. We have, as you can see on the screen, 5 documents in CORSIA for sustainable aviation fuels. 1 containing the sustainability criteria, 2 on life cycle methodologies and values, and 2 related to the sustainability certification schemes. You can imagine the amount of work involved in all these agreements and all these elements, but it really demonstrates the commitment of ICAO and its member states to the reduction of the climate impacts of international aviation. So moving a little bit more on details of the CORSIA related documents and sustainable fuels. As I mentioned, CORSIA allows airlines to claim CO2 benefits of sustainable aviation fuels, but for that, sustainable aviation fuels need to meet the CORSIA sustainability criteria. So this is the first time we could have a global approach agreed by all states to the sustainability of fuels. And it comes in response to many requests for increased harmonization of those sustainability aspects. For the pilot phase of CORSIA, which is 21 to 23, the sustainability criteria requires that SAF should achieve net GHG emissions reductions of at least 10% on a life cycle basis, and that the feedstocks used for SAF reduction cannot come from deforested areas. Work is also ongoing on additional sustainability themes for the next CORSIA phases, included a broader range of environmental and socio-economic criteria. So if we go now on the life cycle benefits of SAF and how they are calculated, we are saying you can deduct, but how do you calculate? And that's where global harmonization was so crucial in that file. So CORSIA elements include 2 options for that. And so you have those 2 documents that are there. The fuel producers can use the methodologies included in an ICAO document called CORSIA methodology for calculating actual life cycle emissions values and calculate emissions values that are specific to a given fuel producers. But another option is to use what we call the default life cycle emission value, which is pre-calculated and provided as a function of the feedstock used, conversion processes, and the region it comes from. A list of those default values is provided in the ICAO document CORSIA, default life cycle emissions values for eligible fuels. So here I highlight some of the common feedstocks from Brazil that can be used to produce SAF. And you can see the relevant emissions reductions when they are compared with conventional fuels. Another important element here is sustainability criteria, right? And we have to ensure that sustainability criteria will be evaluated by the sustainability certification schemes. And those schemes they have to first be approved for the ICAO Council so that they can provide that certification to fuels coming into CORSIA. This sustainability certification schemes need to comply, of course, with the specific requirements for being approved as certification schemes for CORSIA. They have to prove that they are robust, that they can do the job. And for the moment, we have evaluated and approved 2 schemes to perform this role in CORSIA. And we are encouraging more others to join. Please, this is an open invitation to sustainability certification schemes. Please apply for recognition in CORSIA. And the website is shown here. But we also have other policies to foster SAF deployment in ICAO that came from other conferences before. I think I would like to highlight the 2050 ICAO vision for sustainable aviation fuels. It's a call that we had many years ago for a significant proportion of SAF use by 2050. And we called for a quantified long-term goal for SAF specifically defined by 2025. And the second thing that was very important is more policies and a call for a level playing field with other sectors. And that's critical, right? Since the last assembly, we in 2019, also, as I mentioned before, a huge amount of work is happening to assess the feasibility of a long-term global aspirational goal for international aviation, what we call the LTAG. And this work will include combined scenarios that will look into technology, operations, and fuels in terms of what's the timing for their deliverable, what's their readiness, attainability, and the potential CO2 reductions that come with it. And all those results will be then presented to the next ICAO Assembly in 2020. To do that and to support the definition of those goals, we are organizing in ICAO what we call ICAO stock-taking process. We then gather the relevant information on innovative solutions for aviation CO2 reductions from a variety of aviation stakeholders within and outside the sector, and it happens in a very transparent and inclusive process. The next stock taking, the 2021 ICAO stock taking, will be held virtually, and it's going to take place from 31st August to 3 September this year. We have also a series of preparatory events. Please look into our website. There's one upcoming now in May. I also have to say that the 2020 stock-taking seminar that was held was a huge success. We had more than 100 speakers presenting their green innovations, and we are really expecting a higher interest this year. So registration is open. Please, we welcome all stakeholders to come, participate, and provide quantified information to this process. All the details is in the website that you show here. Now, all the information I shared here with you today demonstrate that sustainable aviation fuels are a reality. The technology is ready, but we need to do much more. There are still many challenges that remain for scaling up the use of SAF. The main one is the higher cost comparing to traditional conventional aviation fuels. So further policies are needed to drive SAF costs down. And with that, in parallel, we'll have to really increase production volumes and ensure, that we are decreasing the risks with more certainty on the buying and demand side. A level playing field needs to be established between SAF and other transportation fuels. We have many other transport sectors that are out there asking for sustainable fuels, but we have to make clear that we have to look at the entire grid and see that other sectors, they do have more options to be decarbonized right now. For example, for road, we have electrification. So we'll have to have this really wider look on how we will move forward with this level playing field. Now, looking more into the future, into this decarbonized future, clean energy and green innovation will be key, there's no doubt. We are in ICAO continuing to following the developments on fuels and looking into fuels that can contribute to reducing the climate impact of international aviation. Just of note, among new types of SAF under development, we have this power to liquid fuels, the syn fuels, but also we are looking into lower carbon aviation fuels and the benefits that can accrue from there. Additionally, ICAO is following up, of course, as I said, the development of new aircraft concepts such as electric, hybrid, and hydrogen aircraft. All these technologies have a role to play. If we are to do this effort, the big effort to decarbonize aviation. It's not easy. There is no silver bullet. All measures count if we want to achieve ambitious emissions reductions targets. This is the year of climate ambition, and ICAO stands ready to set the course of aviation's contributions. And SAF is an essential component of this journey. With that, you have more information on ICAO activities on SAF. And I would like at that point to thank you for your attention. Look into our website and you can also send us an email if you want to know more about aviation and sustainable aviation fuels. So on that note, I thank you very, very, very much for your attention and thank you. Obrigada.
Hello, my name is Landon Loomis. I'm the Vice President of Global Policy and Managing Director of Boeing Brazil. It's a pleasure to be with everyone today. I want to thank the organizers of the Brazilian Bioenergy Science and Technology Conference, Biofuture Summit, for inviting us again to participate with such a great group of panelists. Thank you for the opportunity. Before we dive into the topic of the conversation today, specifically about sustainable aviation fuels, I do want to take one moment just to take stock of our industry's commitment to emissions reductions and environmental sustainability in general. Over the last 3 decades, passenger traffic has tripled, and yet your profile as a passenger, the emissions that you produce or represent on that aircraft have been cut in half. In other words, at the same time that traffic tripled, the amount of global emissions that the aviation industry creates has stayed roughly stable at 2%. So how is that possible? How can you grow that fast and yet not contribute to the global total of emissions? Well, the answer is just it's a relentless commitment to improvement, to technological advancement, and to efficiency. That's what our airline customers demand from us. And in fact, they've spent $1 trillion buying 15,000 new aircraft since 2009. That's what they need to be more efficient and effective businesses. It's what we need to win their business. So it's good for the environment, but it's also good business. Now, our industry is not comfortable or content by just accepting the trajectory we're on. We've made additional voluntary commitments to further cut emissions, to cut them, in fact, half of 2005 levels by 2050. Now, in order to meet that ambitious target, we got to do something different. We've got to do more. And the question is, what are we going to do? What technology is capable of bending the emissions curve fast enough, far enough, that we can actually cut our emissions and meet those targets? Our answer at Boeing is that it's sustainable aviation fuels. It's the only technology that exists today that's in use, that's proven. Every day, aircraft fly with SAF. More than 250,000 flights have already flown with SAF, and that number is just growing every day. You can use it and blend it today with existing petroleum Jet A standard jet fuel. You can do that without replacing the engines or the aircraft or the fuel systems. You can drop it in. It's a drop-in technology. And by using SAF, you can decrease the emissions of a given flight by up to 80%. And with additional technological advancements, that number might even increase itself. So we've got an existing technology that is capable, and in our mind, the only capable technology that can bend the emissions curve fast enough, far enough to meet our ambitious voluntary targets we've set for ourselves. Now, at Boeing, we don't just plan to make this a rhetorical exercise. This is one of true commitment. And we've already taken concrete action just over the last 6 months to really establish our leadership role in this topic. In September, we named our first Chief Sustainability Officer, Chris Raymond, who since taking his role has helped really drive the centrality and the priority of SAF and environmental sustainability across the business units and across the functions who are responsible for engineering and operations and supply chain and all of the key aspects of our company that are going to drive our ability to meet these ambitious targets. In December, we announced that our company had for the first time reached net carbon zero for all of our manufacturing and work sites across the world. And in January, we announced, most importantly for this conversation, our commitment that we will certify all of our aircraft to fly on 100% sustainable aviation fuels by 2030. So sustainable aviation fuels, or SAF, is the technology that's going to help us meet our ambitious targets. It's proven, it's deployed in the market today. The problem we face is one of scale. In order, well, just to kind of put that scale problem into perspective, today we produce 8 or 9 million gallons of SAF, and yet we consume 80 or 90 billion gallons of Jet A. That means that we need to scale up the production of SAF by a factor of 10,000 in order to meet the demand. That's the problem we face. Now, as the Boeing company, we look at our commitment to meet emissions reduction targets, we look at our belief in SAF as the technology to do it, and we understand the problem related to commercial scale production. That's where Brazil enters in. Brazil is perfectly positioned to play a decisive role in overcoming some of these challenges. You just think about Brazil's strengths. It's an aviation world leader, a world leader in energy and agriculture. And you take those three things combined, and you've got the right ecosystem for addressing the challenge of SAF. You think about Brazil's established and demonstrated history in building one of the world's most successful and largest biofuels industries in the world, second only to the United States. Brazil today produces 25% of global production, biofuels, larger than the next 8 countries combined. That's the sort of scale that is interesting and is necessary as we're going to tackle this problem inside of our aviation industry. So Boeing, understanding Brazil's central role, has been investing actively here for more than 10 years across multiple areas. One of them is focused on communities. We've partnered with the Roundtable on Sustainable Biofuels and universities like Unicampi to identify small producers of sugarcane and macaúba oil and other indigenous products to help them get certified as a SAF feedstock. We've been successful in certifying some of these small communities, and that has small farmers in these communities, and that has had a big economic impact where they live. Boeing is investing $2 million on initiatives that maximize the social, economic, and environmental benefits to local communities working on SAF. In addition, we've also helped inform the policy environment. We provided research data and inputs to the RenovaBio policy framework and legal framework that was established in 2019, a very positive step in Brazil's creation of a biofuels network. We brought the Eco Demonstrator to Brazil. The Eco Demonstrator is our testing platform where we take real aircraft and we test and deploy new technologies that are designed to reduce carbon emissions, fuel use, and noise. And by testing those innovations on an actual airplane, then together with our partners, we gain valuable knowledge about how to design, build, and integrate those technologies into aircraft in order to gain those efficiencies and that additional emissions reductions. When we brought the Eco Demonstrator to Brazil, we partnered with Embraer, and it was the first time that Boeing had ever partnered with an OEM on the Eco Demonstrator project. We've also worked to launch and to write a roadmap for sustainable aviation biofuels, a roadmap which I see on the screen, but which I also have my copy here. In fact, this document was launched at the 2016 iteration of this conference, of the Brazilian Bioenergy Science and Technology Conference. So we appreciate the longstanding partnership we've had with the organizers as a platform to continue to advance our contribution and engagement with our partners here. Now, what the roadmap did is that it created a national assessment of technological, economic, and sustainability challenges that together we need to address and overcome. We had key partners in the creation of this document, including Embraer, FAPESP, and Unicampi. I'm not going to go through this slide in too much detail, but I did want to put it up here just to show everyone the true breadth and depth and sustained commitment over time that Boeing has brought to our work on sustainable aviation fuels in Brazil. Now, we won't go through all these lines, but there are a couple points I want to highlight. The first is that we've worked with many, many partners. This is not a solo act, and this is not just Boeing working alone. We've worked with airlines like GOL and OEMs like Embraer. We worked with universities like the Federal University of Minas Gerais and Unicampi and USP. We've worked with other industry partners like Agricone and RSB and FAPESP and the Brazilian Biokerosene Research Network. We've sustained this effort over time, working more than 10 years together to help deepen our understanding and conduct the research necessary to map the feedstocks and understand the sustainability aspects of each project. Like I said, Boeing is investing more than $2 million in our engagement with the communities towards these certification efforts. What I'd also like to do is point to this last element on the chart here, all the lines leading towards our SAF Maps project and transitioning that to RSB. SAF Maps is a partnership with a Roundtable of Sustainable Biofuels and the State University of Campinas, or Unicampi. Together, we are currently developing a portal or an electronic database that provides and makes available and useful information about Brazil's most promising SAF feedstocks. It looks at each one of these feedstocks from specific angles, understanding its suitability as a SAF product, its supply chain economics, data about refining, the refining process required in each case, and the sustainability metrics to understand what is the true carbon impact of each of these feedstocks. Together, in this interactive database, this information becomes an invaluable resource for regulators and other government officials, academics, and industry participants to understand the cost and the availability as they continue to build out and design Brazil's new SAF system. That's the kind of partnership that Boeing wants to build and wants to continue here in Brazil. To summarize, we've got very ambitious targets that we have to meet as an industry. We have a great track record, but we've got to do more. The only technology that exists that's going to help us bend the emissions curve fast enough, far enough is SAF. And the challenge we face is how do we scale it up? Brazil is very well positioned to be a partner given its strength in aviation, agriculture, and energy. And Boeing has a long history of working with many of those partners over the last 10 years, building the roadmap, informing the policy process, engaging with local farmers, and working across with our industry and government partners to really drive this forward. So now's the time for action. We really appreciate the opportunity to present our perspective here on this panel. Thank you, the organizers, again, for bringing us all together. And thanks again. Bye-bye.
Hi, everyone. My name is Grassi, and I'm the Business Development Lead for Latin America at Roundtable Sustainable Biomaterials, RSB. So first of all, I would like to thank the BBEST-Biofuture team for the invitation and say that it's a pleasure to be here and be part of this amazing panel with this set of panelists. And today I'm going to talk about how RSB supports the achievement of true sustainability of aviation fuels and how we can promote the growth of the aviation sector, especially in Brazil. So, the aviation sector has an ambitious target for reducing the greenhouse gas emission in 50% by 2050, and the replacement of fossil fuels with low carbon sustainable aviation fuel that from now on I will call SAF is considering the most efficient way to achieve these goals, these targets. However, currently, from the total of 390 billion liters of jet fuel produced in the world, only 14 million, less than 0.5% is SAF. So we still have a long way to scale up the SAF production. But this is the right time to plan and define how we can produce this biofuel. Because SAF can stimulate the social and economic growth, can develop regional communities, and be produced in harmony with ecosystems, besides, of course, mitigation of climate change. And the good news is that there are plenty of initiatives for SAF production in the world, with at least 14 in the Americas, 12 in Europe, and 5 in Asia. And those initiatives encompass the production of both SAF and renewable diesel, since these products are co-products of the main production routes. And if you're considering the production capacity of those facilities, it's expected to achieve a total volume of 7.4 billion liters of SAF and renewable diesel per year. That is a huge volume. And through certification, membership, partnership, and also advisory services, RSB can support several initiatives around the world to promote SAF sustainability, to promote new technologies and innovation. And we are involved in a large-scale project with partners, and great partners, I can say, that you can see here in the left side of this slide. And we are acting in this project as sustainability advisor for SAF facilities, or we are supporting projects for SAF certification, or we also helping the development of SAF credits that airlines can sell to their corporate customers, or we are still working to develop national roadmaps for SAF production. And among these several projects that RSB is involved, I would like to highlight here one in particular and present some of the main results of this project for you. And I'm talking about this project that called Filling the Sustainable Bioeconomy. It's a project that RSB leads and has WWF as a partnership And this project is powered by Boeing Global Engagement Portfolio. And by the way, I'm glad to be here with Landon Loomis from Boeing. It's our honor to be a partner of Boeing and to be here with you in this panel. So thank you again, Landon, for the great partnership. And continue. In a nutshell, this project aims the implementation of sustainability across multiple sectors related to SAF production, support the development of new feedstocks and technologies, and also encourage the transformation of traditional supply chains. And especially in Brazil, this project has three main goals. The first one is the evaluation of viable and sustainable feedstock options for SAF production, as well as the production path will also evaluation. The second one is the development of regional communities and regional supply chains, and also the inclusion of smallholders in the biofuel markets. And the last one is the advocacy and the general support for SAF sector in Brazil. And now I'm going to present some of the main achievements so far, and mainly related to the feedstock availability and also the technical and economic evaluation for SAF production in Brazil. So we know that SAF industry faces economic and environmental challenges, including and mainly, I can say, the economic viability for SAF production when compared to fossil fuels, and also the impact of biofuel production, especially in the land use change. So if you consider that SAF can be obtained from waste and residues, these waste and residues can be a way to deal with such challenges because they have a low cost and a low environmental impact if compared with regular feedstock as biomass, traditional biomass, and crop feedstocks. So to support this sector, we have mapped and quantified in Brazil the availability of waste and residual feedstocks that can be used for SAF production. Among the residues that we have mapped are the sugarcane residues, wood residues, the flue gas, beef tallow, and used cooking oil. And combined with these 5 residues, we evaluate 3 pathways for SAF production: HEFA, alcohol-to-jet, and Fischer-Tropsch. And based on our quantitative assessment, we found that using wastes and residues, we are available to produce in Brazil 90 billion liters of SAF. That is amazing. And an interesting fact that I would like to mention here is that the current demand for jet fuel production in Brazil in the country is 7.2 billion liters. So the good news is that Brazil has enough and a low emission feedstock available for SAF production. Of course, we still need to promote the economic feasibility and understand if it's feasible to produce SAF using these residues. But we need to agree that the availability of feedstock is an essential first step. And if you'd like more details about that, please feel free to contact me or to access our report and fact sheets about this result at RSP website. As I mentioned before, an important point is to evaluate the technical and economic feasibility of SAF production. And we know that making SAF competitive against the fossil jet fuel is still a challenge. And then in order to support that, we are developing a SAF calculator that will support investors, SAF producers, policymakers to understand the different scenarios for SAF production, the business models, the technology development, and also how to create incentives for SAF production. This calculator is almost ready, and we are finalizing in the next months. This is the main interface of the calculator. And I would like to also to highlight here that we are developing this calculator with Agroeconic, that is a great partner of RSP in the technical side. So the SAF calculator is composed by blocks of information that to be filled or specified as an input. As you can see here in the left side of the slide, we have pre-established a background database on pathway description, economic data, and environmental data that the user can evaluate if these parameters meet their requirements or can adjust it with suitable information. In the dashboard, the user can define the pathway and can adjust the parameters that they can use to evaluate their scenario or their case study. In the cash flow, the user also can refine the parameters and add information about transportation, OPEX, income tax, or other data that can be adjusted to meet their requirements. And then the results are automatically calculated and shown in the dashboard spreadsheet. And as the main results, we have the economic indicators that include the minimum selling price, the mitigation costs, maximum feed cost, the maximum feedstock cost, the NPV, the net present value, the IRR, the payback, and some sensitive analysis. And you can see an example of the dashboard spreadsheet here. So as I'm saying, the user can adjust the general assumptions and general parameters to meet their requirements. And here, the user can see the main results that are cost composition, economic indicators, and sensitive analysis. And here in the left side, the user can also check the description of the pathway and the information regarding mass and energy flows. And regarding the cash flow spreadsheet, the user can refine the simulation, adjust some parameters that I have highlighted here in yellow, and also can check the evolution of cash flow along the lifetime of the facility. And we have predefined 25 years. This calculator is not public yet. However, if anyone has interest in testing or is interested to know more about it, please contact me. I'll be happy to share more information with you all. So besides the feedstock mapping and the calculator, the main business of RSP is the development of certification standards for sustainability. And RSP is one of the certification systems recognized by ICAO to certify staff for CORSIA. I mean, to be eligible under CORSIA, the staff must be certified. And RSP has two different options for CORSIA certification, and the options are very similar and differ only in the sustainability criteria. The first one is approved by ICAO Council and considers the greenhouse gas emission and carbon stocks as the main sustainability requirements. And the second one is also recognized by ICAO and considers the principles and criteria for sustainability from RSP. And these principles and criteria are 12 RSP principles that cover social, environmental, and economic aspects. And these principles demonstrate how to produce biomass or use residual feedstock to obtain fuels, products, and chemicals. These principles are based on a management and risk-oriented approach and were constructed based on a consensus among several stakeholders from different sectors, given to the certification systems a great robustness. And continue on certification approach and how RSP can support staff regarding certification. RSB has been worked really hard to ensure the sustainability of SAF through certification. I can say that we intend to engage all the key SAF producers with RSB Core Seal certification. RSB is also involved and is the main certification systems used by several Horizon 2020 projects to certify SAF supply chains. And we are also developing a simplified audit approach for traders and distributors to promote and to incentivize the certification of these operators for SAF distribution. And currently, RSB has several key players related to aviation sector or certified under RSB or committed to RSB certification. And the growth of SAF sector and the concern for sustainability is really clear when we look at the several airlines companies that are member or have declared preference for RSB certification for SAF. And here we can see we have more than 18 airline companies that are RSB members, and we have a lot of them that already declared and are committed with RSB certified SAF. That it's amazing and it's an honor for us, and we are very glad to have these companies and airlines in our community and working with us to construct a more sustainable world. And so to end my presentation, I'd like to present the community of RSB and invite you all to join us to build breeds and ways to achieve a sustainable future. And thank you so much. This is my contact, my email, and I will be very happy to discuss with you all about SAF sector, about SAF production, and about sustainability. Thank you again.
Hello all. Thank you for the opportunity to participate this panel in the BBEST-Biofuture virtual conference. My name is Sami Jauhiainen. I'm responsible for business development in Neste's Renewable Aviation business unit. I will share with you today our views on the outlook for SAF and talk about Neste's investment plans in this market. First of all, what I would like to highlight is that Neste is a purpose-driven company. Our purpose is about creating a healthier planet for our children. And how is it visible in what Neste is today? 3 highlights to mention. First of all, we are the world's largest producer of renewable diesel and sustainable aviation fuels with a capacity of 3.2 million tons. Secondly, our products helped our customers to reduce their greenhouse gas emissions by a total of 10 million tons of CO2 equivalent last year. And this called carbon handprint figure we aim to grow to over 20 million tons by 2030. Thirdly, Neste is very much a renewables company today. Our activities in the renewable businesses contributed 94% to our profits last year. We develop our solutions and operate in 3 main markets: road transportation, aviation, and polymers and chemicals. While most of our volumes are today sold in the road transportation markets as renewable diesel, aviation and polymers and chemicals are really strategic markets for us, as those are the markets where oil use is expected to continue to grow or resume to a growth trajectory after the current pandemic. And also, these are the areas where it is hardest to substitute oil use with any other solutions than the kind of renewable solutions Neste has to offer. Then, moving to aviation. This is really a sector that is at the center of global climate challenge, and why so? Aviation's emissions are let's say only 2 to 3% of the global greenhouse gas emissions. However, that figure is alone not giving the full picture. First of all, because unlike emissions in many other sectors where there are clearer trajectories towards carbon neutrality, aviation emissions are bound to return on the growth trajectory with pre-pandemic growth rates that could mean and denote doubling of flight activity and emissions in the next 15 to 20 years. And secondly, because aviation's total climate impact is much more bigger than the greenhouse gas emissions alone would indicate. It is estimated, for example, by EASA that the total climate impact of aviation, taking into account also the so-called non-CO2 emissions caused by the various pollutants of aviation emitted in high altitudes, is 3 times higher than the greenhouse gas emissions alone. The public opinion has, over the last couple of years, come to recognize the impact of aviation, and it's really visible on the concerns of passengers to do more to tackle those emissions. The transition of the aviation sector to sustainable aviation fuels provides 3 main benefits for the aviation sector. First of all, sustainable aviation fuels are a drop-in solution that can be used in existing aircraft and fuel supply infrastructure without modifications or investments. Secondly, SAF reduces life cycle greenhouse gas emissions by up to 80% compared to use of fossil jet fuel. And such high emission reduction potential is possible because Neste's sustainable aviation fuel is produced 100% from various waste and residue raw materials. Thirdly, SAF provides additional non-CO2 benefits through reduced local emissions and through additional climate benefits that arise from the chemical composition of our sustainable aviation fuel, leading to reduced soot particle emissions and through those to reduced contrail cirrus formation. Neste has been in the market with sustainable aviation fuels since 2019, and we have supplied some of the major airlines since then with our product, both in Europe, North America, as well as in the Asia Pacific region in Japan. Our customers include, for example, KLM, Lufthansa, American Airlines, Alaska Airlines, ANA in Japan as examples. Even though the aviation industry has been in severe difficulties over the past year, the development of the SAF market has not really slowed down. And this is really because the regulators have continued to drive forward ambitious policies, setting binding requirements for emission reduction in aviation and creating policies that either incentivize or obligate the use of sustainable aviation fuels in the aviation sector. And what we see today is such policies developing across Europe and North America in particular. Some of the leading countries in this front include, for example, Norway, that implemented a sustainable aviation fuel blending mandate in 2020 as the first country. Sweden looks to follow on the same path this year. Some other countries probably in the coming years, and European Union maybe with a European-wide blending obligation by mid-decade. The blending obligations are particularly important policy frameworks from SAF investor point of view, that they provide the kind of demand certainty that high capex investments in SAF production require. Neste has started its investments in sustainable aviation fuel production early, already ahead of the development of the regulatory frameworks. And today we can produce up to 100,000 tons of sustainable aviation fuels per year. And we look to grow that figure 15-fold to 1.5 million tons by 2023, when our ongoing investments in Singapore and Rotterdam are completed. Beyond that, we see opportunities for further investments, both with our existing capacity as well as in new technologies that further grow the potential of sustainable aviation fuels and available pools of sustainable raw materials. Importantly, we believe that the potential for those investments is there because the raw materials required are available. One notable study looking into this market was the World Economic Forum and McKinsey Insight report produced for the so-called Clean Skies for Tomorrow coalition late last year. This study showed that the total potential of sustainable raw materials from various waste and residue sources and from vegetable oils grown on degraded land or as cover crops without any risks of harmful land use change effects produces a total SAF potential of close to 500 million tons, which is comfortably higher figure than the estimated jet fuel use in 2030. However, to capture this full potential, what is really required is a roadmap approach, often called three-stage rocket, where the first rocket is about taking the existing commercial technologies and raw materials to full use, scaling them as soon as possible to their full potential, and building the scale-up of future technologies on top of that. In the horizon of next 5 to 10 years, we should have commercially available technologies that use municipal solid waste, agricultural and forestry residues as raw materials for SAF production. And in the next 10 years or so, we should be also able to produce power to liquids type of fuels from renewable hydrogen and carbon captured from the air in commercial scale. We as Neste look to operate and be driving forward all these three steps and be investing in technologies and SAF production capacity in all of these spaces. Thank you very much for the opportunity to present to you today. I look forward to answering any questions that you may have.
Hello, I am Pedro Mancuello, Vice Minister of Commerce and Services of Paraguay. I will present about a main project that is taking place here in Paraguay and is focused on advanced renewable biofuel production. It is the Omega Green plant. To start and put it in context, we all know that in 2017, the International Civil Aviation Organization members agreed on a new 2050 vision for sustainable aviation fuels, which is helping to ensure that conventional jet fuels are substituted with sustainable alternatives to a significant percentage by 2050. This is an important issue because 191 states are cooperating to reach this goal. In addition to the European Regional Airline Association had come out with this ambitious plan to reach zero carbon emissions by 2050. According to Destination 2050, a publication of the Royal Netherlands Aerospace Center and Amsterdam Economics, the European aviation industry is committed to reach this objective and contribute to the goals set in the Paris Agreement through using drop-in sustainable aviation fuels and improvements related to aircraft technology and air traffic management operation, among others. Summarizing, the aviation industry had itself a target for 2050 to halve carbon emissions from air transport, which today account for 2% of the total global emissions. To achieve this, biofuels will play a key role. Biofuels extracted from non-food crops are already being developed as proposed by Omega Green with pongamia trees. The aviation industry transports approximately 2,200 million passengers per year around the planet and is an essential element in a globalized world. According to the International Air Transport Association estimations, in 2050 passengers will reach 16,000 million. This constant growth in traffic means the simultaneous challenge of meeting this demand and reducing the emission it generates. The flight cleaner receipt will come out from greater efficiency in airplanes with improvements in turbines and engines and the use of lighter materials in its structure to reduce consumption, and the intensive use of biofuels that mitigate the carbon footprint. A technological innovation effort in which airlines, aircraft manufacturers, and energy companies are involved. This context takes us to Omega Green. Omega Green is one of the biggest projects of foreign direct investment of the Paraguayan history. An Omega Green biorefinery will be built in Paraguay and it will reach a total capacity of 20,000 barrels per day, producing hydrotreated vegetable oil, also known as renewable diesel, synthetic paraffin kerosene, also known as sustainable aviation fuel or biojet, and green naphtha. This investment includes Honeywell as a partner, as owner of the refinery technology of renewable fuel UOP process creators. Crown Iron Works, an USA enterprise that offers equipment for treatment through renewable raw material improvement for adequate quality for biofuels, and Acciona, one of the greatest enterprises of engineering. Some data of the project. The plant will produce 20,000 barrels per day, equivalent to 300 million of gallons per year. 3,000 jobs will be generated during construction and 2,400 direct and indirect jobs during operation. 20,000 small farmers families will benefit from the additional demand for raw materials. Estimated total investment of $1 billion. Expected commercial operation date for 2024. The government of Paraguay granted a free zone regime for 30 years, guaranteeing the maintenance of the legal conditions of the project for a period of 30 years. Very advanced environmental process. The environmental impact study was completed and the preliminary environmental license was issued on February 7th in 2020. ECB has engaged Control Union as its environmental advisor to support the application process for these three certifications: RFS, LCFS, and ISCC certifications. Construction of the production plant is expected to begin this year. Some strategic advantages of the project are that Omega Green will be installed in Villeta, Paraguay, a region with a high availability of soy oil, animal fat, and renewable vegetable oil, essential raw material for biofuel production. A privileged location allows transport through rivers and main roads, connecting this industrial infrastructure with main ports of the region. Paraguay's energy production is 99% for renewable sources that reduces the impact of fuels produced by Omega Green. Omega Green is expected to generate a large amount of carbon credits by running exclusively on renewable energy. As I mentioned before, three main products will be produced by Omega Green: hydrotreated vegetable oil, synthetic paraffin kerosene, and green naphtha. SEB Group already has signed partnerships with other global enterprises like Investancia for reforestation oil providing from the Pongamia tree, Shell as a consumer of the HBO and the SPK, and Honeywell as the key production technology and services provider. To finalize, Paraguay has a clear path through sustainability and to become a key player in competitive markets like civil aviation global industry. Paraguayan government with a strong private sector support is committed to attract more foreign investments that grants more competitiveness to this value chain and to offer sustainable and high quality products to a global market. Thank you.